television and refrigerators, automobiles could be classified then as your synthetic process.
Professor Carlson, I'd like to interrupt our discussion for just a moment. We have prepared a piece that gives examples of these two production processes, but we would like you to stand by because there are some further questions I'd like to ask.
Every product manufactured falls into one of two production categories. One is called an analytic process, the other is called a synthetic process. An analytic process is one in which a raw material is broken down into its component parts. The petroleum industry is a good example. After the raw crude oil has been pumped from the earth, it moves to a refinery where its molecular structure is broken down by a process called fractional distillation. Some of the useful products manufactured in this way might be lubricating oil, jet fuel, or gasoline for your car. The very opposite of this analytic or breaking down process can be illustrated by the manufacturer of electronics. Here, in a synthetic process, components are built up one by one into a finished product. Other good examples would be the blending of ingredients to create cosmetics or food products. Analytic process and synthetic process. To remember, analytic is a breaking down into component parts associated with the word analyze, which is breaking an idea down into its parts. And to remember synthetic as a putting together, associated with the word synthesize, which is the blending of ideas into a new form.
Professor Carlson, from this piece, we've seen that all production is either analytic or synthetic. But how do you go about doing these? What kind of manufacturing options do we have?
We have the continuous type of production and the intermittent or job shop type of production.
Could you give us an idea of what is involved in each?
In the so-called job shop or intermittent type production, we find that products are made more or less to customer order, and the facilities and the functions are arranged to provide more or less a customized activity. Whereas in the continuous type of production, we think more in terms of the mass production of automobiles or, again, refrigerators, television sets, microcomputers. This we identify with the continuous or repetitive manufacturing processing.
So there's a kind of a rule of thumb here. Continuous applies to products which are mass-produced, while intermittent applies to products which are custom-made. Okay, let's focus on continuous manufacturing for a moment. Could you describe the layout of the equipment and the workflow in a continuous operation?
In continuous manufacturing, we would, again, identify with something like a conveyor belt or any conveyor, a fixed path equipment, where the product or the semi-finished product with its components are brought to a workplace, and then the workers would assemble these and the product would continue on to the next workstation until it is finally completed.
Now, what would we see in an intermittent production operation?
We would find the equipment arranged by specialty. There would be a functional specialty, such as all the drill presses in one area, the punch presses in another area, the paint booth in a particular area, and therefore the product has to be moved between these workplaces with perhaps variable path equipment, forklift trucks, or even operators themselves. And we're not sure from time to time which sequence these products would flow, and therefore we might say that the job shop or intermittent type production is very flexible. We can make anything, but we have to move it with our variable path equipment.
And one final question for now. What determines the type of production layout we use for continuous and intermittent processes?
With the nature, okay, the layout of the plant is dictated to a certain extent by the item. Certainly if you're in a continuous or very high volume type production, this almost dictates that you would put it on some sort of a conveyor line.
Thank you, Professor Carlson. We'd like to come back to you later in the program to help us summarize. But now we are going to visit with managers of both continuous and intermittent production operations. We've already sent crews to record footage of their operations, so we'll look at that as well. Visiting with us now, two managers at the Macintosh plant of the Apple Computer Company in Fremont, California. John Otterstedt is a productions operations manager, and John Livingston is a management information systems manager, both of this highly successful company. John Otterstedt, it's good to be with you.
Thanks, Alex. It's nice to have you at the Mac factory.
John Livingston, thanks for letting us visit.
Well, we're pleased to have you here and hope we supply you the right information.
And also from Torrance, California, we are talking with Dale Larson, Vice President and General Manager of Typeco Graphics Incorporated, a printing company which has been around since the early 1900s. Dale, it's a real pleasure to be talking with you about the printing business.
Alex, we're glad to have you here.
John Otterstedt, let's start with you. Let's start at the beginning. What are your production objectives here at Macintosh?
I guess the major objectives would be that we're trying to produce in a very high volume state a very reliable, high quality personal computer.
John Livingston, the objective is clear. High quality, reliability, high volume. But how did this dictate that you use a continuous production process?
To build in high volumes, we had to incorporate things like a just-in-time philosophy and automate as many functions as we possibly could. The purpose of the automation was to keep the reliability and quality in the product and take away the menial tasks from the operators and let them concentrate on the quality of it.
John, let me continue with you. When you laid out the facilities to produce the Macintosh computer, what kinds of things did you have to consider?
Well, since we're building a electronic assembly and not a metal fabrication or anything like that, you'll notice our manufacturing lines are laid out in a north-south manner. The purpose for doing this is we didn't want to cross electronic assembly through the Earth's magnetic fields to eliminate electrostatic discharge buildup and so on and so forth. The other thing I think you'll notice is that we're a straight linear flow from one operation to the other. There's no queue between each operator, and our whole goal there was to keep a continuous flow on the product. No offline operations, no queue. The objective there was to bring parts in one end of the factory and let them flow right through until we get to the north end of the factory and ship the product out that end of the factory. So we have a straight linear flow on the product itself and use a very small amount of real estate to produce the volumes that we produce.
John Otterstedt, let's talk about the actual production operation. How does your continuous operation integrate people, equipment, and materials flow?
Okay. The material is brought in the receiving doors, and it is brought right to the individual workstation. The operators really never leave their workstation, whether it be the automatic insertion equipment where the material is brought out on demand right to that work center, and then it is again moved to the next step in the process, or the final assembly line where the major components are brought right to the individual work centers. So the operator is either working on the machine where the boards are flowing across the machine, or they're working in an assembly process where the Macintosh goes by them on a conveyor type system, and they never leave that work center.
John Livingston, I believe when we take a look at the actual Macintosh operation, a lot of this will become clear to us. But is there anything you would add about the relationship of people, materials, and equipment?
To summarize the overall system and concept of the equipment out here with the relationship to people is we attempted to make each person stationary in their task and the equipment that they have to use stationary, but there's other supporting equipment that moves the product from point A to point B and eliminates people having to move the product. So we attempted to make the people stationary and concentrate on their task.
And now we're going out onto the Macintosh production line to see what makes a continuous production process tick. And if you'll stand by, Dale, we'll be talking with you when we return.
Fremont, California, the Apple Corporation's Macintosh factory. Using what is among the most advanced continuous production operations in the world, the plant is manufacturing thousands of its Macintosh computers every day. The first thing one observes about a continuous process is the linear design of the production facility. Everything flows automatically from one workstation to the next at constant speed from one end of the process to the other. Literally, components come in at one end of the building and a finished product comes out the other end. The key to the process is what's called a just-in-time inventory system. Incoming materials from the supplier or vendor are scheduled for delivery several times a day, directly to the workstation, when and where they are needed. Smaller components flow to the warehouse where no more than 3 or 4 days inventory is housed. This system is totally automatic. An operator dials in the part wanted and it's delivered to the line automatically. When there's a need for a part, nobody has to fill out a ticket, run across the factory, order from a warehouse, then bring the part all the way back. With the automatic system, the operator can concentrate on the task at hand. The first operation in the production of a Macintosh is called the Automatic Component Insert Area. Here, several dozen electronic components are sequenced on a single reel for use downstream. In a parallel operation in the same area, electronic components are stuffed by machine onto the logic board. Some 2,000 boards a day flow through the production line. In this area, about 85% of the electronic components sequenced on the tape are automatically stuffed. Throughout the process, there are quality control checks, yet the flow never stops, never alters speed. A few of the larger components are inserted by hand in an adjacent downstream area. Again, everything flows automatically from one operation to the next. The logic boards move on a chain-driven belt, and step by step, the build-up process continues. The frame is built. The assembly is soldered, then goes through a solder bath, and then the completed board is checked for performance. In the final assembly area, the board, the plastics, the CRT, and the disk drive are mated. Again, just-in-time materials handling along a linear flow. No one operator releases an assembly until the next operator releases an assembly downstream. Once assembled, the unit flows to what is called the burn-in facility. Here, each unit is operated or aged for 24 hours. During that time, the system, with its self-diagnosing software, is run through a series of tests. If something is not functioning properly, the computer itself identifies the problem. If the unit passes the burn-in tests, it flows to packaging. It is essentially an automatic boxing machine. A box is built around the unit, and it flows to shipping, where it's palletized and a protective shrink wrap is applied. There is no finished goods warehouse. The system flows just in time to the end of the line and onto a truck for delivery. The Macintosh factory of Apple Computer is state-of-the-art in terms of continuous production operations, yet the company is planning even more advanced robotics for the future, and even more efficient people, machines, and materials.
Dale, we've seen this brief piece on continuous manufacturing. Now, let's talk about the other side of the coin, intermittent production, a kind of production that characterizes the work at your printing company. Let me ask you this question. What are your production goals at Typeco?
The objectives of the production system are to try to meet whatever our customers' needs are and produce a product that's cost-effective and efficient and fill their needs.
You said, whatever your customer needs might be. That suggests your customers have different needs.
Strangely enough, every one of them have totally different needs. And all of our products really have to be customized to their particular need.
Let's talk about the actual production, Dale. How long can a custom job take?
A job can take anywhere from 2 days to 6 to 8 weeks, depending on the nature of the job, the complexity, what all has to go into that job for the final product.
You said each product is different. The needs of each customer are different. Does that mean you have to set up the equipment differently for each job?
Every piece of equipment, every one has to be attacked in its separate for what the job is and specially set up for that particular job.
Why does each job require different setups?
There's infinite variety of papers and sheets and sizes and colors and inks that have to be used, whether the job is being produced one-sided, two-sided, or it's a layout of many pages that go together. There's just a whole variety of variations they have to deal with and adjustments made for that.
What about your people? Wouldn't this place special demands on them?
They have to be able to specialize basically in their one craft, but then they have to be versatile enough to be able to deal with and work in other areas and help each other out.
Dale, based on what you've told me about your production requests, how have you laid out your operation to produce the job?
Okay, we've tried to lay it out to be cost-effective and efficient, to handle jobs regardless of what they are that come into us, and to flow through the plant in the quickest and most efficient way.
Well, Dale, I'd like for you to watch a piece we've prepared in your production facility, and I believe it reflects the sharp contrast between your production system and that of Macintosh.
Torrance, California. Typeco Graphics, an experienced and respected printing firm, employs an intermittent production system. Upon entering the workplace, there are a number of dramatic contrasts between this intermittent production operation and the continuous production operation at Macintosh. First, it's not a linear layout. Work doesn't flow in the south end of the plant and out the north. Rather, machines and people are organized around a specific job, and the relationship between people and machines may change from one job to another. Rather than have work move to the people on an assembly line, people move to the work. An intermittent system is highly labor-intensive. A significant portion of the product's cost is for labor. Unlike the production of Macintosh computers, each of which is identical, the product here is custom produced to fill the specific needs of the customer. The design, colors, paper stock, all the elements of the project are worked out in advance with the client. Once the artwork is completed and approved, a negative is shot. From this negative, a printing plate is made by a process of photo engraving. In the print shop, there's a choice of machines and a choice of different human skills required to move the product towards completion. The choice of equipment and steps in the process differ with the job itself. Once the plate is mounted on the appropriate press, the printing begins. In this intermittent process, production itself may be interrupted in order to inspect for quality, to make sure that both machines and people perform as planned. Here, there is a constant rechecking and modifying and adjustment. The production of a printed piece is a multi-step process. Once the press run is completed, the finished pieces might be trimmed, folded, or stitched, depending on the requirements of the particular job. Production in a print shop, unlike that in the Apple factory, is driven by the differing needs of the job. The print shop job demands a product that is a one-of-a-kind item. Only intermittent production can deliver custom-tailored products.
I'd like to thank our three hosts for letting us visit today. I believe the contrast between Macintosh and Typeco Graphics was quite dramatic. Dale, it was a pleasure.
Thank you very much, Alex, for being here. I hope we could help open up some eyes on what we're trying to do.
John Otterstedt, John Livingston, thank you.
Well, it's my pleasure.
Well, thank you very much for coming.
Before we close, I'd like to rejoin Professor Carlson one last time to help clear up a few loose ends. Professor, we've seen both intermittent and continuous production operations in action. Yet there's one final aspect of production that needs clarification, and that's production control. The element that brings it all together, makes it happen. What activities are involved in production control?
Production control involves four functions of production planning, routing, scheduling, and then dispatching.
Would you describe these for us?
Production planning is a very pervasive type of function and could involve a great number of activities, all of which should come together in pretty much a business plan. That is, what are we going to make and what are we going to, when are we going to make it? And involves, you might say, a master schedule. From the master schedule, then, we want to do our routing, and that is our planning in the form of where should these activities be performed, how should they be performed, to get the components made and to get the final product assembled and shipped. The scheduling, of course, is that activity which, once done, must be kept current. If we don't keep the schedule current, we may dispatch according to an obsolete schedule and cause more chaos in the shop than if we really had left the shop to their own devices, which very often they do, if they don't believe the schedule that we have established for them.
Where does quality control come in then? How do we assure quality?
And quality control is the term which we associate with perhaps the broad activity of trying to identify the criteria or identify the aspects of a product which determine its quality. And so we have to establish and define those quality characteristics. Second thing, of course, is to identify that those characteristics are adhered to, and so we have inspection departments.
Professor Carlson, thank you so much for allowing us to come visit. It's been an informative time.
Thank you, Alex.
In our discussions today, we have learned that production is the use of people and machines to convert materials into finished products. Now, production isn't just mass production with conveyor belts and assembly lines. There are various processes which can be used to produce a product, and the one that is used is influenced by the type of good that's being produced. Production is where all the memos must be converted into action. A company is not going to survive if it doesn't efficiently produce a quality product that meets a market need. Until next time, I'm Alex Burton, and this has been The Business File.
The preceding program is part of a college credit course.
You can groove your golf swing with the all-new Groove It. Just place a Groove It face piece on any iron or wood and swing away. You can practice with any club, and the ball will stick to the club face. The Groove It shows exactly where on the club face you're hitting the ball. Then you can correct it. It's so simple to change the Groove It from one club to another. You can use your Groove It indoors and out, so don't worry about the weather. Just keep swinging your Groove It. Here's how to order yours. Call 1-800-433-2700 now. Operators are standing by. Call 1-800-433-2700 for your Groove It. Order your new golf swing for only $14.95. That's 1-800-433-2700 for your new Groove It. Sorry, no CODs, only $14.95 plus shipping and handling.
The Cable Television Network entertains New Jersey.